terms that came in this formula, right? And if I substitute D equals to 1, then it will be just F into Q1 Q2 upon R square. That is the formula that we usually keep using. I'm not explaining K. K is, you just take it as a constant. Again, it's a physics thing. Permittivity of a space, let them define, then me. I don't need these numbers, but because I need the concept of this, I have given you a formula. For me, it is more than enough that you understand the force is inversely related to distance and directly related to magnitude. This is it that I need. This is it that I need. But still, if I am giving you equation, I must make you understand some basic of it. I won't. That will be done in physics. I will explain you atomic structure. That's it. So can I move to next page? Have you finished copying it down from the board? So right now till electrostatic is done, just some basic to you in understanding. Now I'm going to next page. You want this? Anybody still writing? Finish it up fast. Done, very good. So see next page, I repeat the same formula here and no talking in the class. So it is K, Q1, Q2 upon R square, and I say since D is 1. Open air experiments, right? So now this force, everybody understand, for like charges, this is a repulsive force. And for unlike charges, it's an attractive force. So this is basic that everybody knows, still I have put it on the board. So after the electrostatic force, I am showing you next formula to calculate potential energy. So basic about potential energy is any particle which is at a rest, then whatever is the energy associated, that we termed it as potential energy. And very crudely, when a particle is moving, then whatever is the energy associated, that will be called as which energy? Kinetic. So two energies, right? Total energy, we usually a crude formula is potential plus kinetic. And potential is when anything is at a rest. But understand, this potential is actually calculation of so many things that we will see as we go ahead. But do I have a formula to calculate potential energy? Yes. How do we denote this? We denote it with U. And see the formula of U, very close to what we did just now, with only one difference in the denominator. This is it, that is differing in the denominator. So I have explained you all the terms. Up here and here, see the difference between electrostatic force and potential energy. No R square, only R. That's it, what is the difference? And here now for like charges, you will have a positive value. energy is positive. And when energy comes positive in chemistry, positive means repulsive force. When the energy decreases in chemistry, we say going towards stability. When energy increases in chemistry, we say going towards instability. So in chemistry as a rule, energy and stability will be inversely proportional. So if the energy is plus plus increases, then something is unstable. High energy particles means unstable. Something has low energy, then stable. Now a particle is at very high energy. What it will do to become stable? It will lose energy. It will give out energy. Is that clear? So energy high is less stable. Energy low is stable. And how from high to low? It comes by losing energy. So anything that is losing energy, we say going towards stability. Is this clear? Okay. So yes, for like charges, you will be plus, and for unlike charges, you will be minus. And what I am giving is more than enough for you to understand atomic structure upcoming lectures. More than enough. And you won't find this in NC. So when there is a charged particle, now third discussion, in CRT there was a charged particle and there was a potential difference applied, right? So there is some electrical force acting on it. Everybody will agree. So can we calculate that electrical force acting on a charged particle? Yes, I am giving you formula. That's the third thing that I am discussing. Why there is a continuous talking in the class? I'm teaching this part because I thought you don't know this. So now this is denoted by F, but I write small e. So this small e stands for force, but electrical force. See the formula, Q into E. So what is Q? Q again is the charge of a charged particle, right? Q will be the charge that a charged particle has. I've already defined you Q. What is E? E is electric field strength. So is this part clear to you? Yes. So when you know that we carried out experiments on electron, when electron was coming from cathode, and there was you won't understand anything as you missed all the initial lectures, right? Yeah, go. So when electron was coming from cathode and then I had applied a screen, do you remember those experiments? So I told you we will place an electric field. And then we saw electron going towards positive plate. So when it was going, it was attracted by electric field. Did you understand that? So it was pulled, right? So there is some kind of a force. Which force? Electric force. What? There was an electric force that was pulling, isn't it? And that is what I am defining here. And that will be decided by what is the strength of that field. Everybody understand? It cannot be same based on what strength I have applied on that electric plates. That is the main thing. And the charge, product of these two. Charge increases, electric field strength will increase. And even E increases, it will increase. Am I clear? It's very simple. Now the next point is the magnetic field I am discussing. So same experiment, I told you that if an electron is traveling straight, we had attached a U-shaped magnet perpendicular to the direction of propagation. Electron is traveling this way, then the magnet was held this way, perpendicular. I had explained you that. So for that, now I am defining magnetic force little bit here. This also you have to understand. So I am discussing magnetic force due to applied magnetic field on a charged particle. Right? Everything that is discussed is on a charged particle. That's what I need in atomic structure. So there is a complete chapter in physics magnetism. There is a complete chapter in physics called electrostatics, and they are very big. Electrostatics so goes on like for a month, it will go on. Very big chapter. So like I'm teaching you something like top formulas. That's it. Nothing else. The rest will be taken care by your physics teacher, not me. But all that is not done, so let me give you some idea here. So this force, let me write with a different color. This is applicable or this happens. This gets generated only when magnetic field is placed perpendicular, not otherwise. So that's what we did in that experiment. So important is this force is applicable. Okay, so first point clear. I'll explain you every term, but the point is all this will happen only when the magnetic field is placed perpendicular. And when it is placed perpendicular and this magnetic force gets generated, then what happens to charged particle? It goes in a circle. That's what I told you from radius of curvature, if you go back and read. So when you apply this, the particle won't go now straight. It will go in a circle. Okay, so if this condition is applied, okay, where am I? Is applied perpendicular to the moment of charge particle and then charge particle undergoes circular motion. Is it clear till here? Now yes, in the formula the terms that I have used. So what is Fm? Fm stands for a force but due to magnetic field. What is B? B is strength of that magnetic field. Every magnet won't have equal capacity, right? Magnetic strength changes. And what is V? V is velocity of this. This is not V actually, this is mu. So I'll write what these terms mean, say here. V is strength of magnetic field. And this is mu, velocity of charged particle. So I've defined everything. So charged particle, when it is moving, it will have some velocity. In this chapter, I will teach you how to calculate velocity of an electron. We will learn in this chapter only. So when electron is moving, it will have its own velocity. And strength of magnetic field, everybody understand? You can increase or decrease that. And all that is directly proportional to magnetic force. And when that is applied perpendicular to charge particle, and if it is moving straight and magnetic force is applied perpendicular, then it will start moving in a circular manner. Okay, and that is the whole reason. See why I am stressing this point so much. That is the whole reason electron is moving in a circular manner in atom. So this I will connect when I will teach you atomic structure. Why it goes round? Why it is not going straight there? Right, it is going circular because some magnetic fields are operating there inside the atom. Some electrostatic force of attraction is there. There is some energy associated with electron. All this I need. So I am covering it up today. Is that clear? Little bit. Nu. Nu. Q is charge that I defined first point, right? That is mu, mu. So he is showing me this Greek alphabet. So this is mu. And what I am showing you is this is nu. Not same. We use that for wavelength and all. I think in 10th standard little bit has happened. Okay. Can I go ahead? Next point will be kinetic energy. So potential energy is over. Now why I have to teach you kinetic energy? Understand? Somebody was asking me when that electron was going, why it is not getting stick to the positive plate? Why it is not stopping there in CRT, right? This was the question asked by you in the class. It starts with cathode. It is going towards the positively charged electrode. Then why it is not stopping there? It is not stopping there because it has kinetic energy. It is moving with a great kinetic energy. So let us understand little bit about that energy. Let us understand the magnitude and how to calculate that. As electron in atom is moving and any moving particle, whatever is the energy attached is kinetic. Right? So can I go on the next page? All clear in the class? So which point? Point number 4. 5. What was 4? Magnetic field. So point number 5 we discuss, not 4, 5. So point number 5 we discuss about kinetic energy. Now I'm specifying. I'm not in general discussing. Again, this will be done in physics. Too much of it. I need very little out of it. So I'm discussing when a potential difference of V volt is applied on charged particle. And I'm specifying at rest. Then kinetic energy acquired by charged particle is given by. So understand, I am defining the exact situation that I gave you in cathode ray tube. You want, you can turn the page and see cathode ray tube. When the key is switched off, there was a key given. So when the key is switched off, means there is no potential difference across the two plates. The potential difference here is denoted by V volts. So when there is no potential difference, will the electron move from one plate to another? Answer is no. As it will acquire, it will get kinetic energy only when in presence of potential difference. Initially it is at rest. It is not moving in the CRT. I am not talking about any atom. Bolo. Want to go out? Yeah, you can go. Right? So, I'm not talking about inside the atom. Now, why inside the atom it is continuously moving? I need to explain you then. It never rests. Inside the atom forever. Electrons are moving. So, we have to understand this. But here in CRT, we generate them from atom. We separate a positively charged ion and a negatively charged ion by applying high voltage and low pressure. We generate them. We take them out of the atom. Okay, when we take them out of the atom, and if there is no potential difference across the plate, it will be at rest. The minute you switch on the key, there is a potential difference applied, and then that electron will gain kinetic energy. What is the formula? That kinetic energy is equal to Q, that is charge, into V, that is voltage applied. Similar formulas are coming everywhere. Let it be electrical force or kinetic energy or magnetic energies. I need strength and I need charge. These two things. And of course, you also know this formula from the school. Your kinetic energy is equal to half. And what is the formula now? You use V there. I am using here for velocity nu. Now I am using for velocity nu because we use V for voltage. And we don't want you to get confused. Am I clear? So it is not mv square now, m mu square here. That mu is the velocity with which the electron is moving. What is m? M is the mass of the electron. Right now you know the mass of the electron. As we go ahead, I teach you how to calculate velocity with which an electron is moving. Substituting in this formula, we can calculate kinetic energy of electron. I will be doing in this problem as we go ahead. This chapter, same chapter. So everybody clear with these formulas? All term clear? I'm just writing the terms if you are confused. M is mass of, I in general write here charge particle, but in chemistry that will be electron most of the times. Then this nu is velocity acquired. What is V? Potential difference in volts. So this description is for this formula. This I have given you extra. So when I say when a potential difference of V volt is applied on a charged particle at rest, then kinetic energy will be given by this formula. And this is only when you know the velocity. At this stage you don't know how to calculate velocity, so you can keep calculating kinetic energy in CRT by this formula. You know charge present on an electron, and if somebody gives you voltage, you keep getting the answer of kinetic energy. Is this clear? So all cathode ray tube experiments, you can use this formula to get kinetic energy. And yes, I mean, I can connect the two and I can also write this equation. So if this data is given, voltage is given, you know the electronic charge, you know the mass of electron. From this formula also you can keep calculating velocity of electron. I equated the two. Did you got it? Now what is the unit of these energies that I am talking about? Tell me, unit of energy, what it is? Joules. So let me show you some conversions here. SI unit is joule. In chemistry we do use joule, but we have our own unit called electron volts. EV, have you heard of this unit? For energy, I'll define you what is 1 electron volt. Very simple to understand. Once you understand electron volt, chemistry problem becomes very simple. Okay, so we also will be using joule, but see what is electron volt. This electron volt is denoted by small e and capital V, EV. So what is 1 EV equals to, I am defining 1 electron volt. So see, I define the electron volt is defined by using this formula. See, what is 1 electron volt? It is the kinetic energy acquired by an electron which is initially at rest under the potential difference of 1 volt. So your electronic charge into 1 volt is 1 eV. Is that clear? So I put that in the formula. I will give you conversion. So I am using this formula which I derived just now. Kinetic energy is Q into V. Now for this, what is charge? Charge present on 1 electron. What is volt? 1 volt. Yes or no? Now what is electronic charge? This electronic charge, I know that it is 1.6 into 10 raised to minus 19, and what is the unit? Coulomb, and into voltage 1 volt. So what is the answer I get here? I get this as 1.6 into 10 raised to minus 19, but coulomb into volt becomes joules. So this is nothing but I have given you a conversion between electron volts and joules. 1 electron volt is this much joules. See how that comes. Number remains same, only the unit has changed. These are some very basic fundamental things I am giving you. You will keep needing in so many problems. Everybody understood how it came? In Q into V formula, substitute 1 volt and substitute 1 electronic charge. That's it. Yes. It's an energy, right? AC off?
Few minutes.
I'm sweating.
Just few minutes.
No.
5 minutes.
There is a pillar behind you where you are getting AC. AC is coming directly on these people, not you at all. Can you see that pillar behind? Chalo, are you clear till this? Now I'm just giving some simple problems so that you understand how to use this, whatever is taught to you today just now. And then I will start solving the mole concept. Okay, couple of problems so that we know how to use these conversions and some simple things. Can I go ahead? And why are you talking? Alok, come and sit here. Come, 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 fast. Get up, get up. Get up, sit here. So three of you are wearing masks so that nobody can see you're talking or not. I understood now. Come and sit here. Get back, get back. Come here. Empty bench. All the three come here. You don't have to sit there. No need, right? Come fast. Get up fast. Get up fast. Wearing mask doesn't mean you can talk throughout the lecture. Can I go ahead? Now see, can you solve these simple problems now? So I'm just putting some simple problems. They are not at all difficult, but they will teach you how to use these formulas that we have learned. Everybody can solve this. Nothing great in it. Finish this. No problem. Absolutely. I can take up to one also. Acha, ask Chechi to send my PM. She forgot. Chalo, do this. No. What I will do, how I will teach, tell me. Complete room is closed.
Then can we go back?
Yeah, you can go back. Who? Three of you. But no talking. If I see you talking, then I throw you out of the class. And now you please shift inside so that people behind can see. You're such a tall boy. You should sit in the corner. And keep Timothy at this corner. Okay, so tomorrow first bench, let Timothy sit here and you sit on the corner. So people from behind can see, right? You're comfortable here? So finish, right? Two problems. Nothing in this problem. first question, so simple. Just now I give you the formula. Can you read, substitute, get me the answer? What is the answer? 1.2. From where 1.2 comes? No? What is the first problem? Find the kinetic energy of electron. Which formula you use? QE. Right? KE equals to QE. I told you very clearly, we cannot use at this stage formula half mv square as we don't know the velocity part. So we will be using this formula. See, I'm solving it for you. See where, what you have done wrong. So kinetic energy, state substitution in the formula QV. And see how I do it smartly. I know that the charge is E and the voltage is into 75 volts. So this is simply 75 electron volts. Now how much is 75 electron volts in joules? So you can have an answer in electron volts down, then you don't need to do any calculation. Is that clear? E is the electronic charge, V into voltage. That's it, is the answer. 75 EV. Is everybody in the class understanding? That is what is the importance of EV. How much is joules? If the answer given below are in joules, then you will have 1.6 into 10 raised to minus 19. I did it at the place of E. That's the charge. Multiply by the volts. 75. Now the answer will come in joule. So if the answer given in EV, we don't have to do anything. Whatever is the voltage, that's the energy. Just put it in EV. Are you getting it, everybody in the class? Is this point clear? You must know how to smartly calculate. You do calculate, but not smartly. Smart calculation saves time. So what is the answer coming now? This is what you did and you got 1.2. So 1.6 you multiplied by 75. Yes, it will be 1.2 because it is 3 by 4, right? As simple as that. So 3 by 4 of this. Why 10 power is changing? It will change, right? By 2 digits. If I am writing 1.2, then it will change. But I leave it just like that. Go ahead. See the next now. Can you solve? So here it is not about electron. Had it been electron, see now. Here, if they say find the kinetic energy on electron initially at rest, accelerated by potential difference 100 volt. What should be our answer? 100 eV. Getting it? It will be 100 eV. But now what has changed? I changed the particle. Okay, so what will change? The charge. Do you know what is the charge present on alpha particle? I will discuss some particles separate. See on the board. So if it is, so I am giving you some note. What is alpha particle? Your alpha particle is nucleus. Thank you. Nucleus of helium atom. I think little bit we did in discussing electrons discovery. So this is same as He with a charge 2 plus. So what is the charge present here? With a clarity plus 2. So what is the whole meaning? You won't substitute 1.6 into 10 raised to minus 19. It will be 2 into 1.6 into 10 raised to minus 19. The magnitude doubles. And anyway, we are not taking the signs here. Is that clear to you? So similarly now, this is alpha particle that I gave you. Let us revise. If they talk about proton. So this is for alpha particle. See, what if the question is on proton? So what is a proton? Proton can be represented as H plus. And what is the charge present? It is plus E. So electronic charge only, whatever is the charge present on specifically one electron, same, but with positive sign. I'm also writing here for electron, which you know still I'm writing as I'm putting everything at one place. So this is what is your electron, what is the charge? Minus 1e. Then if the question is on deuteron, so what is deuteron? Isotope of hydrogen. How do we represent? D plus. What is the charge here? Plus 1 only. And if it is triton, what is the charge? T plus only. So understand whether it is proton, deuteron and triton, charge remains same. What changes? Mass, not charge. Did you understand this part? And yes, neutron we have discovered. So in all this, if somebody talks about neutron, then what is the charge present on neutron? 0. Q will become 0. And when you apply QV, energy will become 0. Are you getting it? Any doubt here? All clear? I will also give you representations. How do we represent alpha particle? It is alpha, the charge is plus 2 here, the mass is 4 here. For proton, we can use P. The charge is plus 1 here, the mass is 1 here. For electron, a small e with charge minus 1, mass 0. For deuteron, capital D, charge plus 1, mass 2. For triton, capital D, charge 3, this plus 1. And for neutron, charge 0, mass 1. Gave you all representation as well. Now can you solve the problem on the board? Any doubt, ask me. So what is the answer? Come and tell me. Answer in electron volts, how much it is? 200. And you convert, then you will multiply by 1.6. Everybody understood? So once you know what is alpha particle, the problem is over. See, everybody is through. I will teach you I'll give you the next problem. No 5 minutes break. My lecture is getting over at 12, right? Why you need 5 minutes break in 2-hour lecture? And anyway, you roam down up. Why you need a break? You already took your personal break. Right? Chalo, let me solve this for you. I hope everybody is through here. So same formula, your kinetic energy is Q into V. What is Q? Electronic charge. What is V? 100 volts. So this is 100 eV. If we have to express in electron volts. But this is 2E, sorry. So it will be not 100 eV, 200 eV. And by conversion it will be 200 into 1.6 into 10 raised to minus 19 and the unit will come joule. So I hope nobody is confused now in the units, conversions and what we are doing. Is this clear? All clear? All clear? Next problem. So this is little different than what we did. So two simple problems on the board. One is talking about accelerated, another is talking about deaccelerated. So accelerated means, what is the meaning of accelerated and deaccelerated? Deacceleration is retardation, right? Exactly. So there it is retardation and here it is elevation in the same. So when it is accelerated, this problem, when it is accelerated, whatever is the initial kinetic energy, due to acceleration, some kinetic energy will be added. And you add the two and get the final answer here. And deaccelerated, whatever will be the kinetic energy, from that you will have to subtract. Deaccelerated is reduction. Accelerated is addition. Did you understood this? Can you solve? Today my lecture is physics. What to do? No choice. So here, to calculate kinetic energy, but final. So what is final? I am already having alpha particle whose energy is 200 electron volts plus a Q into V is added. Right? So what will be that Q into V? 50 volts, right? So it is 200, but it is not electron, alpha particle. So plus 2E into 50. So what is this? 200 electron volts plus 100 electron volts. Answer of this is 300 eV. And in joules you can accordingly convert. Everybody knows how to convert electron volts to joules. Is that clear? I don't want anybody ever in next 2 years making a mistake in conversions, as I have devoted like a lecture in that. Because believe me, you lose a problem at the end if you don't know conversions. You do everything correct. And while ticking, an error happens due to conversion. That's very sad. So is the next problem, are you through? What is that must be happening on a last bench now? I don't know, some property of last bench, I think. Whoever goes and sits there, das must be. Whoever. I'm not blaming you, I'm blaming the bench. Did I say you did something? No. The problem is of the bench. So what is the answer coming? Here you have to take a ratio. Yeah. Everybody is understanding? So here what I have to do? So I have to take a ratio of kinetic energy of alpha particles upon kinetic energy of which particle? Next is proton. So kinetic energy of proton. This is what we have to do. Now both of them, alpha particle, let me focus, is moving with 100 electron volt kinetic energy, and the whole thing is this word, deaccelerated. So initial kinetic energy is 100. Now deacceleration means it will get reduced. By which value? So 100 minus what? Whatever is the charge multiplied by what? So So what is the charge on alpha particle? Charge on alpha particle is 2e into 20, and here also it was moving with 100 volt. The charge is 1, right? Proton charge I gave you plus 1 is the charge on proton. So I write minus 1e into 20. So what will be this? 100 minus 40. So this is 60. And this is 100 minus 20. So 80. The ratio is 3 by 4 or 3:4. Is this clear? Very simple numerical. Every lecture after going home, please go through it, see to it that you know everything, revise everything properly, try to solve the problems again by covering the solution. These are the basic ways by which you now revise in IIT lectures, not just reading. Reading nothing is there, right? Mainly the problem part. They are teaching you something. Every problem is teaching you something. Can I go ahead? Now I discuss in electrons discovery and proton discovery, charge to mass ratio. Let me talk about that. Can I go on the next page? So this is called as specific charge. In general, it is Q by M. So denoted by Q by M. So what is this? It is charge to mass ratio. Of an particle. So why I wrote E by M? Because our charge is electronic charge for electron also and proton also. So same thing was E by M that we did. Everybody understand? But in general, in physics, it is Q by M. But in chemistry, it gets reduced to E by M. Did you understood this? So I'm comparing for you now. I'm also giving you comparison below. So Q by M definition is of any particle. You missed my last lecture where I discussed specifically E by M to them. So I'm defining this E by M to that part that I discussed with them. And in general, what is written on the board is for Q by M only, right? Now see, what we did was for electrons and protons. I'm comparing, see on the board. We calculated this. J.J. Thomson calculated in CRT and Goldstein calculated for proton also. So here, but I'm writing now Q by M only as I'm taking more particles also. So what is the charge on electron, tell me? 1e. That's what we are taking. And I'll compare Q by M so that you understand the magnitude and everything here. So charge is 1e. What is the mass of electron? Now see magnitude wise, okay, I had actually given this last week as a homework. I don't think so anybody has done that. So I'm only explaining. For all practical purpose, I told you mass of proton is equal to mass of neutron. Now, how much heavy proton is to electron? Your mass of proton is equal to 1840 times mass of electron. You can check this if you have done the homework. comparison to solve problems, you must know how much heavy. So proton is negligible and this is this heavy. So what is mass of electron? Mass of proton upon 1840. That's what I substitute here to compare the two. So it is mass of proton upon 1840. Is this part clear to everybody? This is Q by m for an electron. What is Q by m for a proton? One electronic charge upon MP. And same if I have to compare, say for alpha particles also and say for neutrons also. So what will be the Q by m for alpha particle? 2 into electronic charge. Now alpha particle mass is 4 mu, matlab 4 times mass of proton. Yes or no? So it will be 4 into mp for alpha particle. And for neutron, there is no charge, but the mass is equal to that of proton. So can we compare this? And can we understand who has higher, who has lesser Q by m? So this is nothing but 1840 into E upon MP. And this is 1 E upon MP. And this will be half E upon MP. And this will be 0. So see, I am drawing an important conclusion for you to understand. Lowest charge to mass ratio is of neutron, then of alpha particle, then of proton, and then of electron. This is increasing Q by m. Is this part clear? This way you can compare whatever particles are given with respect to say proton, it gets easy. So any question in which they ask you find the ratio of specific charge, you can solve now. Are you getting it? CRT advanced, also atomic structure goes as an important chapter, mains also and advanced also. I think 2 or 3 years ago a complete matrix match came of 8 marks from atomic structure, not from this part, of course, from the part ahead, but complete 8 marks matrix match coming from one chapter. So this is important what we are doing from your advanced point of view. And there is nothing called weightage. You will see so many videos, so many things in circulation, they give weightage. Believe me, it's random. Now 1 year atomic structure came for 8 marks. Does that mean every year it comes? No. And this is what advance is about. There was a meme circulated after advance paper this year on 17th of May. Today the answer key is out by IT advance and next Monday will be advance result. So after 17 May, as you are aware about NEET paper leak, right? So after that paper, which was good paper, next day in a faculty group, there was a meme circulated. Even if it would have been leaked, I mean, people outside don't know how to solve only, so it doesn't make any difference. So it was that tough. So IT advanced paper gets leaked. I mean, nothing happens because people don't know how to solve. It's not like NEET, everybody can solve and everybody can get full marks. It doesn't happen as far as IT advanced papers are concerned. They're so difficult that faculties fight for the answer. They're that difficult paper. A couple of questions are always ambiguous in every paper. Every paper there will be 3 to 4 questions. Very difficult. Okay, for a faculty also it takes stress to solve those questions. So even if that paper is leaked in a normal place, nobody can solve, kind of a thing. A below average student Open book test also you gave. I make you sit in a library, say open any book there. Okay, take 6 hours for 3 hours paper, open any book and solve, still you won't be able to solve. This is how that paper is designed. So even if it is weak, it doesn't matter much because the paper is so strong. That's how a paper has to be. Getting it? If you dilute, make it easy, then all problems start. I'll give you last problem now on this, and I'm solving couple of problems from the mole concept, and then that's it for today. Last problem on this. Everybody understood what I did here? Mark this important, we read it. And this is what I did with you. But it was not written Q by M there. It was written E by M, which is same thing. Everybody understands? Chalo, see the next. One last problem on this. Then I'll continue this tomorrow. So what is the number 5? Number 5 problem 6? 5? Chalo, all those who have understood specific charge will be able to do. Chalo, Mohit, no masti. What happened, Bharat? After half an hour, you realize that your bag is not with you. So what is deuteron? What is the mass? What is the charge? I gave you the representation of deuteron, right? So your deuteron is mass 2 and charge plus 1. And your alpha particle is mass 4 and charge plus 2. Can you just substitute and finish? So you need to take a ratio of Q by M of deuteron is to Q by M of alpha particles. So what is the charge on deuteron? I will write 1e. And what is the mass? 2 into mass of proton. And for neutron also we write proton. So everybody knows what is this 2. This is 2 is 1p plus 1n. But we keep representing as np. Easy to solve. And here for alpha particle, that charge is 2e and 4mp, in which we know that this is 2 protons. Who is disturbing the class, playing in the class? That side the noise is coming. Is this clear? My ears are very sharp. Mass down. Chalo, solve this. So what is it coming? Easy to solve, right? Now, so this is nothing but 1 by 2 into 2 by 1. So what is the ratio? 1:1. All done. Yeah, don't tell me. She had come in between, right, to tell me what time to end the lecture. Vincent ma'am had come, right, to inform me what time to end the lecture. So it is little more than 10, 12 o'clock. So in that I'm solving now this paper. That's a surprise. So we go ahead. Why you want to know everything? Oh, you sit here. Yeah, don't worry. Okay, sir will come little late. Till that, I'm teaching. No, I'm just solving this last paper now. Couple of problems and I go out. It's not much, little bit. So after I go and till next faculty comes, you have some time, right? Let me push this. Till what I had solved last lecture, tell me 6 problem, 7 problem. I'm talking about paper 2. 6 problem, chalo. Problem number 7. Which says the molality of. So what is asked to us? How much is the molality of 15% weighed by volume solution of H2SO4? So see what is the meaning of, and see this exercise I am doing, boys there, because you have a doubt and difficulty. Otherwise I can continue teaching my syllabus if you guys are not interested. But your scores are not full, right? Not even a single person has scored full, means, and others are mainly, you saw that graph which was sent to you. So mainly your parents, basically, mainly everybody is between 60 and 70, mainly, majority of the class. So those many questions you are unable to do. 60 means 10 questions in 25 you will do. If I consider not attempted, right? 15 questions right is 60 score. So I'm solving in the class, discussing each and every problem so that you improve next time. Am I clear? So pay attention. And this is important problem. They are asking you molality from W by V given, right? So 15% and into the bracket written W by V H2SO4 solution. So the whole thing lies in understanding this. Tell me who will tell me in the class what this means. What is 15% weight by volume solution? How many gram of solute? What is the volume of solvent here? Pullo. Yes. No. 100 gram. No. See, this is where you have gone wrong. Understand? The one who can identify this correctly, maybe after that will go correct. So tell me, focus and tell me what is 15% W. So 15% W is 15 grams of solute, that is H2SO4. No doubt. Now turn and check your W by V formula. I want everybody to turn and check. Tell me what is in denominator. So how much will be volume of solution? 100 ml, not 85 grams, not 100 grams. So 15 gram of H2SO4 in 100 ml solution. Now once you get this, what is the meaning? Which data you have now? You have this as your weight of solute and this as volume of solution. What is asked to you is molality. Everybody remembers molality formula. How do we calculate molality? What all the things I need to calculate molality? Number of moles of solute upon not volume. Turn the page, see and tell me specifically. This is the reason you don't know formulas. I ask you to learn formulas, make a formula sheet. What is in the denominator? Number of moles upon what? Kg of solvent, not solution. Understand this. So number of moles of solute upon what I want here is mass of solvent in kg. So now let us see one by one. Do I have a data to calculate number of moles of solute? Answer me. Can I calculate number of moles of solute? Yes. Why? I know mass of solute. What I just need, molecular mass. I can get number of moles of solute. Is everybody in the class understanding this? So I can know this. Let me finish this. Then I will focus on the denominator. Is it clear? So what will be number of moles of H2SO4? It will be the weight of solute which I know upon the molecular mass of solute. And at the place of solute I can write H2SO4 here because it is H2SO4. So I just leave it like this. I'm not solving. I just leave it as 15 upon 98. We will solve at the end. This is how you have to do. Don't waste time in between. Maybe some number gets cancelled eventually as we go ahead. Now what I want mass of solvent. And what I have is volume of solution. And yes, one more data is given in the problem. What is that? Density data. So they do give me density data. How much is that? Density data given, I'm writing somewhere. So density is given as 1.1 gram per cm cube. So I have volume, I have density, but both are of not solvent, of solution. Understand this part. So from this data, okay, I'm having density of solution and that will be equal to mass of solution upon volume of solution. Can I use this formula and get mass of solution? Yes or no? I have this density, I have this. Can I get this mass of solution? Yes. So see what is mass of solution. Your mass of solution is density given to you in grams per centimeter cube and into volume in centimeter cube only, that is 100. So how much is this? 1100. What will be the unit? Just 110, right? I have to give decimal. What will be the unit in this case? Grams. So this is mass of solution. What I want, mass of solvent. So how I get now mass of solvent? Solute. Mass of solvent will be equal to mass solution, which is 110 minus mass of solute, which is 15. So it will be 110 minus 15 grams. So it will be 95 grams. Now substitute everything in molality formula. So your molality is number of moles, which is 15 upon 98. And because that is in grams, I will have to multiply by conversion factor 1000. My answer will come in mole per kg. Solve this and take the answer. Is this clear? This is how you use the density data. How many of you got this problem correct? I don't think so. In the class, you got it correct? This way only you did? Or you made some mistake? See, sometimes compensatory mistakes can get you right. But that is not the way to move further. Right? Moving further, you must know the correct way to solve. Is it clear, everybody in the class? Which answer comes after solving? Answer comes 1.6 after solving. So molality of this solution comes 1.6 mole per kg. So question 7, answer is D. Can I go ahead? Just one more question and I'm going. That's it. One more question. So this was big, next is small. Let me finish that. And that's it for today. Everybody understood this? So everybody needs more practice of this kind of a problem, density problems. And then I will also solve a problem, molarity to molality, molality to molarity, and all that. Right? We will do it. So next problem, problem number 8. Say 6 grams urea dissolved in 180 ml of water, mole fraction. So your mass of urea here 6 grams. Your molecular mass of urea is 60 grams per mole. Your mass of water is 180 ml, same as 180 grams. And your molecular mass of water is 18 grams per mole. So you calculate number of moles of urea, that will be 6 upon 60, that is 0.1. And you calculate number of moles of water, that is 180 upon 18, that is 10. And say you substitute in mole fraction of urea, which is number of moles of urea upon water plus urea. So this is 0.1 upon 10 plus 0.1. So this is 0.1 upon 10.1. And there is option available. Answer is D. So your question 8, the answer is D option. And I think majority of you might have got this correct. Very simple problem. No calculation also. Straight substitution in the formula. So tomorrow I'll start from 9. Is that clear? That's it for today. What happened? Yeah, I will be solving every question, but now there is somebody else's lecture. No, I'm solving. I'm here only. Don't worry. I'm solving every question. Tomorrow, let us start early and do more of this and finish this paper, right? Chalo, see you. That's it for today. Your sir is coming.